Hi everyone. Today let us talk about profiling Python code with cProfile and line profiler. Now, profiling is the process of analyzing a script's execution to measure the performance characteristics like execution time, memory usage, how frequently functions are called, all of it. Profiling helps to identify the bottlenecks and optimize the code for efficiency. Now, why do you have to profile a Python script? It helps you identify the slow functions or slow lines of code which you may consider to rewrite to optimize. It also helps us detect unnecessary computations or redundant loops. It also helps us to optimize memory usage for larger dataset, and it improves application performance and responsiveness. Now, profiling is essential for optimizing the Python code by identifying the performance bottlenecks. Two commonly used profilers are cProfile, which is a function level profiling, and line profiler for line by line profiling. cProfile provides an overview of function execution times, helping to identify which functions are most time consuming, while line profiler provides a detailed breakdown of execution time for each line in the function. Now, I'll quickly demonstrate how to profile code using cProfiler as well as line profiler. Now, profiling is essential for optimizing the Python code. cProfile provides an overview of function execution times, helping to identify which functions are most time consuming, right? So here I define a small function, def your function. So it just prints that this is a function. Now, if I import cProfile and run the function using cProfile, so cProfile is a built-in module for profiling the functions, profiling the code. It tracks the function calls and execution times. If I run this function using cProfile.run, so while it prints the output of the function, it also tells that there are 30 function calls in 2 milliseconds, right? And you can see that your function has been called first. Next, you see a lot of functions that are inbuilt and that happen in sequence by default, right? Similarly, we can go a little more deeper. This line where I import pstats, this module allows me to analyze and manipulate the profiling data generated by cProfile. So with the help of it, I'll be able to write it into a file also. So I create an instance of cProfile when I say with cProfile as PR using a context manager. And using this, I ensure that profiling is automatically started when entering the block and stopped when you exit it. So you don't need to call enable and disable manually. Next, your function is the function that I was talking about a while ago. So it just displays hello, nothing more than that. Hello, this is a function. And now I create a stats object from cProfile object, profiler object, which is PR. The stat objects contains the profiling data, which includes the number of function calls, the execution time for each function in the profile, and strips the directory path from the function names, making the output easier to read. It ensures that we only see the function names and execution times without the full file paths, and saying the sort states as cumulative, statistics as cumulative says that I sort the profiling results by cumulative time. Cumulative time represents the time spent in a function and all of its subfunctions, giving us an overall view of where most time is spent. Other options of sorting include time, which sorts by the time spent only in that function without bothering about the sub functions, all of it. Now, when I say print stats, I am only printing the top 10 stats based on how many calls are made. And now, when I run the same function using this additional functionality, I only print top 10 and which functions are the ones that we are talking. We have a getter function being called, we have an exit function being called, all of it, right? So this gives us a little polished version or polished print rather than giving us a file name differently, right? Now, a similar analysis can be made when I write a function intentionally where I have a slow sum function where I introduce the sleep function to induce delay, to simulate delay, and there is a fast function where the computation is very less, right? I also use simple returning of I and I star star 2, like I is squared, right? So I call that function a slow function where I have a heavy computation as well as a sleep function introduced to simulate delay, where there is a faster function where you have lesser computation. And now I write a main function that calls both the functions, right? You have a slow function, you have a fast function, and it calls both the function. Now, if I wrap this function using cProfile, I can also use the percentage prune magic command to profile the main function. If you see, slow function, how much time it has taken, and fast function, how much time it has taken. It is also the result, the value final result. At the same time, if you see, there are totally 20,125 function calls made in 1 second, right? Now, this is how you implement cProfile. Now, when it comes to line profiler is more into line by line profiling. It provides a detailed breakdown of execution time of for each line in a function, right? So I'll have to install the line profiler. So basically what I'll try to do here is I'll create a line profiler instance, register my function to be profiled. I enable the profiling, run the function, and after the function completes, I disable the profiling. Now I'll print the detailed line by line profiling statistics, right? So again, I'll have to install this. I already installed this, so I don't have to reinstall it. And I import the line profiler from line profiler. I define a function very simple. So which squares and sums up, sum of the squares is what it is going to return. So what I'll try to do is I create an instance of line profiler, add my function to it, and enable the profiling, and then call my function, and then disable the profiling after my function is executed. And I'm going to print the statistics of the result. So the function line 3 takes this much time. Line 4 takes this much time. Line 5, how many times it has gotten repeated? Line 6, line 7, all of it. So this is how it shows my line profiler, right? This is how the total time taken is 0.03 seconds. So the line of the line in the function that is being profiled, the time taken, the number of calls, how many times each line was executed in the function, right? And total time spent on the line across all the calls is all given. This is how line profiler helps you analyze the time taken or time spent on each line of the code, each line of the function when the program is executed. In this way, profiling Python code helps you understand if by any chance any line is written not so efficiently or any function is extremely laggy, all of that. So we have seen the demonstration with cProfile as well as line profiler. Thank you.